Hi, so we want to prove this statement, right? This whole expression. Now, what we can do is we can use a common denominator to say 11n to the 7 plus 7n to the 11 plus 59n divided by 77 equals to our original expression. Here, if this part is divisible by 77, then it will be an integer, right? So we gotta look at the cases where this number is divisible by 77, which base. So if a number is basically divisible by 77, right? If it's divisible by 77, it will also be divisible by its prime factors, which are 7 and 11. So if we show that 77, no, if we show that a number is divisible by the both of these numbers, then it will be divisible by 77. So basically, this comes from the Chinese remainder theorem. And we can then say that we can write two different expressions then. 7 divides this thing, right? Which we can then further expand into saying 7 divides 11n to the 7 plus 59n. So 7 will always divide the 7, so we exclude it from here. Similarly, we can do the same for 11th case, which we are gonna get 11 divides 7n to the 11 plus 59n, right? Here, what we can do is, let's take this 7, the 7th case, right? And we can say 7 divides n multiplied by 11n to the 10th plus 59. Yep, it's gonna be actually 6, right? Yeah, 6. And this implies that 7 either divides n or divides this expression. And we only know that 7 divides n for n, which n is a multiple of 7. And for other cases, 7 should divide this thing. So we gotta look at that case for all n. So 7 divides 11n to the 6 plus 59, right? Similarly, when we do the same for 11, we are gonna get 11 divides 7n to the 10th plus 59. Now, taking the 7th case again, we can write, instead of that expression, we can write 7 divides 4n to the 6 plus 3, right? Because when you divide 11 by 7, you get a remainder of 4. When you divide 59 by 7, you get a remainder of 3. Here, we can, let's say, to see it clearly, we can use modular expressions. So we can use this modular expression to see it easily. Now, why did I do this? Now, realize that this is a prime, right? And this is prime minus 1. So what do I imply? I imply Fermat's little theorem, which basically means that this n to the 6th is eventually gonna be 1, right? For those who don't know, just check out Fermat's little theorem. And we basically can just eliminate n to the 6th to get 7 divides 4 plus 3, which is 7 divides 7, which is always true. For 11, it is the same. We can again apply Fermat's little theorem to this 10, right? Because 11 is prime, 10 is prime minus 1. We can apply Fermat's little theorem. For the 11th case, we are going to get 11 divides 7 plus 4, which is 11 divides 11, which is also always true. So always 7 and 11 is gonna divide this expression, which basically means that 7 and 7 is gonna divide this expression, which means that this expression will always be an integer. So that's basically the proof of it. I hope you liked it. We did some number theory, but I don't think it's That's intense. Yeah, that's all for this video. If you have any question, please leave a comment and have a great day.